All right, hey there, class. Mr. Pusky here. Hope you're having a good day so far. Today we're doing 6.5 day 2. Essential question is continued from day 1, which is how do we divide polynomials? We have a couple theorems we're going to cover here, and then we're going to be covering, finding zeros. So this is going to be, we're going to do some factoring, and we're also going to be setting each part equal to 0, doing the zero product property it's called, and solving. So let's get right into it here. So the first theorem we're going to talk about is called the remainder theorem, and basically all it says is a polynomial f of x or any function like that is divided by the quantity of x minus k, then the remainder equals f of k, which is just basically like plugging in k and substituting. So in other words, the remainder when you divide synthetic or long division is the, get my thing here, is the remainder for direct substitution in the given polynomial for that value of k. So direct substitution is different than synthetic substitution. Direct substitution is where we plug it in. We literally would plug into, so if you had y, f of x equals 2x minus 4, and we had x equals 2, you would plug in, so f of 2 would equal 2 times 2 minus 4, right? We plug it in literally to the equation up here, which is 2x minus 4, okay? Synthetic substitution was a little bit different, where we use the polynomials and the coefficients. So, okay, let's do the remainder theorem here. So it says, use the remainder theorem to find the remainder of 2x squared plus 13x minus 7 divided by x plus 6. So we're going to split it down the middle here into two parts. So the first part, so what the remainder theorem says is that if we divide, the remainder is going to be what we do when we plug in using direct substitution. So first thing we're going to do, I see that this is x plus 6 here, which is a nice binomial of the first degree. So we can actually use synthetic division, which I like a lot easier. I think it's a lot easier. So our k, we need to find our k value. So our k, if you remember from the last lesson, k is going to be the opposite of positive 6. What's the opposite of positive 6? It's going to be negative 6. So we're going to do synthetic division over here. We're going to do negative 6. And we're going to put our coefficients that we're dividing by. So we're going to look at this right here, which is what we're dividing. We're not dividing by. We're dividing by x plus 6. We're going to put the coefficients. So we have 2x squared. So we're going to put a 2 here. We have 13 right here. And we have negative 7 right here. So we're going to draw a line, keep a line for some space for some numbers. Now we're going to do synthetic division. So we're going to bring down the 2. We always bring down the 2 first. Okay. See if you can finish this off. Sorry, I'm doing this for you. Maybe you can try to figure out synthetic division here by yourself. See if you can do it on your own. All right, welcome back. We brought down the 2. So 2 goes right there. What is negative 6 times 2? That's going to go up here. That's going to be negative 12. What is 13 minus 12? Well, that's going to be 1, or 13 plus negative 12. We multiply negative 6 times 1. That's going to go up here. That's going to be negative 6. And we have negative 7 minus 6 is going to be negative 13. So this is our remainder, and our answer is going to be down here. Our answer, if you recall, the 1 is going to be our constant. We work backwards here. This is 0 degree. This is first degree. So it's going to be 2x plus 1 is going to be our answer. And our remainder is going to be negative 13 over x plus 6. We put it over the divisor, which was x plus 6 in the original problem. So this is our answer. Okay? But what this theorem is saying is if we take the negative 13, actually if we plug in, we do f of our k value. So if we do f of k, okay? If we do f of k, but f of k, and k in this case is negative 6. If we do f of negative 6, we plug into this original equation up here, we should get negative 13. Let's see if that's true or not. So I'm going to plug in, so f of k, so we're going to do 2 times, we're going to plug in negative 6 wherever we see an x. This is going back to old school substitution. So we got 2 times x to the, negative 6 to the second, plus 13 times negative 6, minus 7. Then we just keep bringing down the f of negative 6 and keep going straight down. So negative 6 squared is 36 times 2 is 72. 13 times negative 6 is negative 78, and minus 7. Then we simplify that, we should get f of negative 6. And when we do this, if you subtract 72 minus 8 minus 7, you're going to get negative 13. So it looks like the remainder theorem worked. So if we divide by x plus 6, or yeah, we divide by a x minus k value. It's going to be the same thing. The remainder is going to be the same thing. It's called the remainder theorem. The remainder is going to be the same thing as using direct substitution, where we just plug it into the original value, and as you would get if you were just doing synthetic over here or regular long division for your problem. Okay? All right, moving on. So the factor theorem is the next thing we have here. So a factor theorem says that a polynomial f of x has a factor x minus k if and only if f of k equals 0. Only if and only if f of k equals 0. So if the remainder is 0, then x minus k is a factor. And that makes sense because if there's no remainder, then you're not going to have to divide it by anything. No remainder means that everything factors perfectly, right? So if you do, like, for example, if we do 30 divided by 5, right? How many times does 5 go into 30? Well, it's 6. So that means that 6 goes into 5 perfectly, right? If there's no remainder. So I guess in this case, yeah, x minus k, if we're dividing by x minus k, that means it goes into the polynomial perfectly, all right? And that means that it's going to be a factor. It means it's going to be a perfect factor, okay? So let's do this here. So we have, is x minus 5 a factor of 3x squared minus 8x plus 16? It says, can we use synthetic division here? Well, the answer is, how can you tell? Well, if you look here, we have a binomial with a first degree binomial, which is x minus 5. So the answer is going to be yes, because we have x minus 5. That's a perfect binomial we can use here, okay? So let's set it, so we're going to do, so we need to find our k value. So if it's x minus 5, our k is going to be the opposite of negative 5, which is going to be positive 5. So let's use synthetic division because that's a little bit easier here. So we're going to do 5. We're going to use 5 for our synthetic division. We're going to put the coefficients here, which is 3, negative 8, and 16. Make sure there's no missing placeholders there. So we have squared, then x, then then constant. So we're not missing an x to the third or anything. So we're going to put 3 right here. We're going to put negative 8 right here. And we're going to put 16 right here. Draw a line. See if you can do this synthetic synthetic division on your own, actually. Give it a try. All right, we're going to bring down the 3. So we got, bring down the 3 here. What's 5 times 3? It's going to go up here. Well, that is 15. What's negative 8 plus 15? Well, that is 7. Then we do 5 times 7. That's going to go up here. What's 5 times 7? That's 35. And then we got 16 plus 35 is 51. So this is our remainder. If it's a factor, we should have no remainder. So is this going to be a factor here or no? The answer is going to be no. We're going to put no because remainder is not equal to 0. And that makes sense, right? So if you have a remainder, it means it doesn't divide evenly. And if it divides evenly, it needs to be a factor. So like 5 times 6 are both factors of 30 up here. And that's why it goes, so 5 and 6 are both factors because they both divide into 30. But if you do this and you have a remainder, that means it doesn't divide evenly, so it's not going to be something that multiplies into the 3x squared minus 8x plus 16, basically. So our answer for this, if we were doing this, would be 7. We'd have 3x, and we'd have, just to kind of get in the habit of this, we'd have a remainder of 51 over x minus 5. That would be your final answer if you were just doing the division, synthetic division. Okay, but our answer is this right here. All right, moving on. All right, next thing we're doing is we're factoring. So it says factor the polynomial given that f of k equals 0. Well, if f of k equals 0, that means we have no remainder, all right, which means it's going to be it's going to be a factor. So what does that mean? That means f of k equals 0. That means that negative 2 is a factor, or x plus 2 is going to be a factor. And then we'll say negative 2. We'll say negative 2 is a 0, actually. Dang it. Gotta erase this. So what we're going to say, actually, is that negative 2 is a 0, and x plus 2 is going to be a factor. But let's go ahead and solve this here, okay? So we're going to factor it. So when we factor, we're dividing. So we're going to do, can we use synthetic division here? We actually can because we have x plus 2, which is a perfect thing we can use here. So we're going to do synthetic division. So I'm going to use our k value is negative 2. So we're going to put negative 2 here. We're going to put our coefficients here. So we have x to the third minus 5x squared minus 2x plus 24. We're dividing by x plus 2 is what we're dividing by, but we're using a k value of negative 2. That's what we do for synthetic division here. So we have a 1, we have a negative 5. We're not missing any placeholders here. We have a negative 2 and a 24. Draw a line, leave some space. What's the first thing we do here? See if you can figure this one out on your own. See if you can solve it. Bring down the 1. What's negative 2 times 1? That's going to go up here. That's negative 2. Negative 5 plus negative 2 or minus 2 is negative 7. Negative 2 times negative 7 is 14. Negative 2 plus 14 is 12. And then negative 2 times positive 12 is negative 24. And look at this. Lo and behold, what's 24 minus 24? That is 0. So that means this is correct, that x plus 2 is a factor. So, and our answer, since we have no remainder, is going to be 12. We have negative 7x is going to go right here. And then we have x squared, right? Because it goes 0, first degree, second degree. So this is what's going to be one of our factors. This is what it divides into, okay? So when you divide by x plus 2, you're going to get that. So how we're going to write this is I'm going to write x plus 2 in front. And then I'm going to take this, I'm going to put it over here. Okay? Because now we have to factor and set each part equal to 0 here. Well, we're actually just going to factor. We're not going to find the zeros, okay? So x plus 2 is a factor. We're just looking for factors in this problem. We're not looking for zeros. We'll do that in the next problem. So we have x squared minus 7x plus 12. Okay, so now we need to factor each part. X plus 2 is factored. There's two terms. There's no GCF. There's no square. It's not a difference of squares, not a difference of cubes, nothing like that. But this term right here, this x squared minus 7x plus 12, is there a GCF, first of all? There's no GCF. How many terms do we have? We have 3 terms. Is it a perfect square trinomial? The answer is no, because 12 is not a perfect square. Is it a smiley face method? Well, let's give it a try. Let's try smiley face method. I'm going to put x plus 2 right here. And then we're going to do, we need to factor this. We need to do smiley face. We're going to go ahead and do this. We need factors of x squared. Well, that's easy. That's going to be x and x. We need factors of positive 12 that are going to add to negative 7. And the factors of positive 12 that are going to add to negative 7 are going to be minus 4 and minus 3. So this is going to be our factored form here, and this is as far as we can go. We can look at x minus 4, we can't be factored. It's a first degree. X minus 3 can't be factored, so this is it. We factored it. By using synthetic division, we found what it divides into, and then we divided it down more by doing some factoring. All right, I think we have 2 more examples to do here. I kind of like synthetic division a lot. I think it's a lot of fun. All right, it says given 1 0 of the polynomial function, find the other zeros. Okay, and remember, it says setting a factor equal to 0 gives us the zeros of the function. Okay? All right. So number 1, it says we have f of x equals 9x cubed plus 10x squared minus 17x minus 2. And negative 2, this equals our k value. Let's just put k right here. Okay? So our zeros automatically, our k value, one of our zeros is going to be negative 2. And the reason why is because if we have a k value of negative 2, we're dividing by x plus 2, right? Because k is the opposite of this thing here, so it's going to be x plus 2. So if you set x plus 2 equal to 0 and solve, you're going to get negative 2, so that's going to be one of our zeros automatically, okay? All right, so we're going to do synthetic division here. So we're going to put our k value, which is negative 2. Let me zoom in a little bit. K value is negative 2. We need to put our coefficients. So our coefficients are going to be, we have 9. We're not missing any terms here. We have 9, we have 10, we have negative 17, and we have negative 2. That's all that goes in right there. All right, we're going to do synthetic division. See if you can do this one on your own. Getting lots of practice. All right, let's go ahead. We're going to bring down the 9. And then we multiply 2 times negative 2 times 9 is negative 18. 10 plus negative 18 is negative 8. Multiply 2 times negative 8, which is going to be 16. Negative 17 plus 16 is negative 1. Then we have negative 2 times negative 1 is going to be positive 2. And negative 2 plus 2 is 0. So this is correct. It means it factors perfectly. There's no remainder. And now we need to come up with our answer. So it's going to be, we're going to go backwards. We have 0 degree, first degree, second degree. So we have negative 1 we have negative 8x, and we have 9x squared. So that's what's going to divide down nice to. So our factored form is going to be, we'll go like this. Actually, I'm going to redraw that. So it's going to be, we have x plus 2 was one of the factors. Then we have 9x squared minus 8x minus 1. So this goes right over here. Now we got to factor this. All right, we're going to set it equal to 0 now. Okay, so x plus 2 is factored. Let's look at 9x squared minus 8x minus 1. First things first, let's keep x plus 2 here for now. You don't need to put the x plus 2, I guess. Well, you should keep with the x plus 2 because it's not really equal to that without it. But we already know that the x plus 2 is going to equal negative 2 because you subtract 2 from both sides and set it equal to 0. But it's good to just show everything to make sure we don't miss anything. All right, so how many terms do we have for 9x squared minus 8x minus 1? We have 3 terms. Oh, first of all, is there a GCF? There's not a GCF. We have 3 terms. Is it a perfect square trinomial? It looks like it could be, because 9x squared is a perfect square and 1's a perfect square, but this should be a positive right here if it was a perfect square trinomial. So it's not a perfect square trinomial, so that means we're probably going to do smiley face method. So we need factors of 9x squared. Well, we're going to do 9x and x. We'll just try 9x and x. You could also do 3x and 3x, but we're just going to try 9x and x. And then we need factors of negative 1. Well, that needs to be positive 1 and negative 1. So where should I put it? It needs to add up to negative 8x. So I'm going to put the negative 1 with the 9. Put negative 1 with the 9 and put plus 1 with the x, because then it's going to be negative or plus 1x and negative 9x, which is going to equal negative 8x, which is perfect. Okay? So now we set each part equal to 0. We do x plus 2 equals 0. We do 9x plus 1 equals 0. Oops. And we do x minus 1 equals 0. This is how we after you factor and you solve, we set each part equal to 0. Subtract 2 here. X equals negative 2. Subtract 1. 9x equals negative 1. Divide by 9. So x equals negative 1/9. And over here we add 1. So x equals 1. So our zeros are these answers we have down here. These are going to be our zeros. So we're going to put up here for our zeros, we're going to have negative 2. We're going to have negative 1/9. And we're going to have 1. And those are going to be our answers. Okay? All right. Why don't you see if you can try example 2 on your own, following what we just did. See how you do. Give it a try. All right, sounds good. Let's fill this in here. So we have f of x is x to the third minus 8x squared plus 4x plus 48. 4 is equal to our k. 4 is equal to our k, which means that we're dividing by, it's not the opposite of 4, it's going to be x minus 4. And our 0 automatically is going to be whatever the k value is, which is going to be 4. That's one of our answers, okay? Well, actually, you should divide and see if you get a remainder of 0, but because we know it's going to be a remainder of 0, we're going to go ahead and assume it's going to be a 4. So, but here we go. So we're going to divide, we're going to do synthetic division because we have x minus 4, which is a lot easier than long division. So we're going to put 4 right here. We're going to put our coefficients. I'm not missing any placeholders here, so I'm going to put 1x to the third, negative 8, 4, and 48. Draw a line underneath. Go ahead and see if you can do this one from here. All right, we're going to bring down the 1. Make sure I'm doing this right. Good. Then we got to multiply 4 times 1. What's 4 times 1? Well, that is 4. Negative 4 plus 8 is negative 4. Multiply 4 times negative 4, which is negative 16. That's going to add to negative 12. 4 plus negative 16. And then 4 times negative 12 is negative 48. We know we're doing it right because this is going to add to 0. That's our remainder, which is perfect. So now we got to form our answer here. So our remainder is 0. So we have negative 12 as our constant. Negative 4x is our first degree. And then x squared is going to be our thing here. So we're going to do x minus 4. We're going to factor this. Times, and then we're going to do x squared minus 4x minus 12 equals 0. So let me just explain something really quick here. if you were to distribute this, of x to all this and the -4 to all this, you would get back to this original problem over here, okay? So if we're by dividing, we're actually kind of factoring as division and distribution as multiplication, okay? So that's kind of what we're doing. Let's keep going here. So let's go ahead. So x minus 4 is good. Let's look at x squared minus 4x minus 12. First of all, is there a GCF? No. How many terms do we have? We have 3. Is it a perfect square trinomial? No, because -12 is not a perfect square. So we're going to factor, we're going to do smiley face method. So we got x minus 4. Then we're going to do our smiley face method equals 0. So our factors of x squared are x and x. Our factors of -12 need to add to 4, -4. So what I'm going to do is I'm going to put x minus 6 and x plus 2. And hopefully you guys can see that pretty quickly here. That's going to add up to -4x in the middle, and it's going to add to, or multiply to -12. All right, now we're going to set each part equal to 0. X minus 4 equals 0. X minus 6 equals 0. X plus 2 equals 0. Solve by adding 4. X equals 4. Adding 6. X equals 6. Subtracting 2. X equals -2. So these are our zeros, are our answers, our solutions. So we got 4, we have 6, and we have -2. Let me fix that 6. We have 6, and we have -2. And those are our zeros, are our answers. Thank you so much for watching. Have a great day, and we'll talk soon.